Good morning, everyone. My name is Catalina Klausen. I am part of the Sustainable Energy Research Group at the University of Canterbury. And today I'm going to show you some preliminary results of our project, which is called Exploring Future Energy Demand, ULTI 2050, in New Zealand using narrative scenarios. And first, I would like to acknowledge my supervisory team, which is Dr. Rebecca Peer, Dr. Jannik Haas, and Dr. Vicente from the University of Canterbury. So also I would like to acknowledge the project that I'm part of. I'm part of the carbon dioxide removal project funded by the Ministry of Innovation and Employment of New Zealand. This project involves iwi, industry, and also government partners. And it focuses on technical investigation and market investigation of how can we implement carbon dioxide removal technologies in New Zealand. And I'm part of the system package. So it's focusing on national scale and deployment pathways. So before thinking about future demand, it's important to mention that today exists a spatial mismatch between where the electricity is generated and where it is consumed. As you can see in the figure, in the energy transition pathway, we usually want to meet energy demand at the same time that we trying to decarbonize the whole energy system. So understanding how energy demand might grow is important to know how supply is located, and this is crucial for our security of supply. So having the required installed capacity is to meet demand at any time is important for security and stability of the grid and to provide demand to energy consumers. So why demand can increase? Well, first, technology development. Nowadays, new data center proposals, for example, are reaching installed load of 3.2 gigawatt. Also, EVs and heat pumps are improving their efficiencies. So all these technologies can impact really the energy system. Also, population growth. This factor can impact the energy consumption from heating sector, transport sector, and also lighting and appliances. And also, we need to reach net zero by 2050. So electrification of the heating and also transport sector is key. So all these factors can impact the energy demand increase.
So close to that, it's actually designed
Okay.
Here.
Yeah.
Up there.
Back here?
Yep. Just leave it there.
Okay.
It stops the.
Okay. Yeah. Okay. So current projection, to plan accordingly, we need projections. So current projections of the ministry and also the the Ministry of Innovation and Employment of New Zealand has a report where they assess 5 different scenarios of energy demand projections, but they focus these projections in economic growth. So even useful, there are some gaps. First, the lack of detailed assumptions in a way that we can replicate this work. Also, the approach does not focus on net zero emissions by 2050. They do not reach electrification rates by 2050 in any of their scenarios. And they're also not considering any carbon dioxide removal technology, even though the IRENA, the International Renewable Energy Agency, has claimed that is one of the main pillars to reach net zero by 2050. So also they're missing emerging sectors or underestimating different drivers. As I mentioned before, data centers, or they are not including direct air carbon capture. We cannot predict the future, but we can trying to understand how this might work. So this we're trying to develop a range of scenarios that explore full magnitude of energy demand to reach net zero by 2050 and to incorporate different drivers. So the methodology that we follow was first, we used as a baseline the Energy Efficiency and Compensation Agency and Ministry of Business, Innovation and Employment data. Then we did an exhaustive literature review to understand how the global data look like. Then we did a scenario development, defined limitations of each, and also we defined different assumptions by a scenario. Then we created adoption curves. We incorporated global projections and different domestic gross domestic product and population growth. Then, as a result, we have the project data until 2050 based on scenario limitations and global trends. So the drivers that we consider for this work is first direct air carbon capture and storage, which is a carbon dioxide removal technology. Then we also incorporated transport sector. We incorporated road and non-road transport. Then in the heating sector, we incorporate industrial and residential and also cooling. Then in power, we assess appliances and lighting. And chemical feedstock, we incorporate the hydrogen production and the carbon that we need to capture to produce methanol, ammonia, and also to decarbonize the steel production of New Zealand. We also incorporated emerging proteins, which is a driver that incorporates lab cultivated meat, precision fermentation, and like emerging proteins. Then we have desalination plants, which is basically convert sea water into drinkable water, and data center where the information is housed. So the scenarios that we came up with was first national targets, the late transition, accelerated with local innovation and cheap electricity. It's important to mention that we reach net zero by 2050 across all the scenarios, but through different pathways. So first, we have national targets, which is that current trend continue, and we reach net zero emissions by electrification of the transport and heating sector. Then we have the late transition, and the important part of this scenario is that we want to show the risk of lowest innovation or inaction in the energy system. Then we have the accelerated with local innovation, where we are incorporated local production of hydrogen and advances in emerging technologies. Then we have the cheap electricity scenario, where we are also incorporating local e-fuel production and big data centers. So the way that we did the adoption curves was first we used the national data to understand how the projections are currently. Then we incorporated global trends to understand how this local data is escalated by the global trends. Also, we assess different technology development of the different drivers. Then we incorporated the gross domestic production and population growth of New Zealand. And then we try to assess that how we can reach net zero by 2050 target through these different pathways. So as results, here we can see the late transition and the cheap electricity scenarios, where you can see the different drivers' contribution to the energy demand. In the left, we have the late transition, where we don't incorporate new drivers as chemical feedstock, desalination, data centers, are emerging proteins, and we are reaching a high level of energy demand. In the cheap electricity scenario, in contrast, we have different emerging drivers, and we are reaching kind of similar energy demand of both. So as you can see here, as we are incorporating different drivers, the national targets, the late transition, and cheap electricity follows logical energy demand increase. But the late transition is one of the is even bigger than national targets and accelerated with local innovation, just because we are using direct air carbon capture, which is a really energy intensive technology. Also here, we can see the different drivers across all the scenarios. In power, we have the same energy demand across all the scenarios because we have escalated by population growth. Heating sector, we are considering that we are including heat pumps and also replacing natural gas by hydrogen. In the transport sector, we are including road and non-road transportation. So we have different range there. The technology of direct air carbon capture is just needed in the delayed transition scenario. And then we have chemical feedstock, where we are including in the cheap electricity, We are including the carbonization of ammonia, methanol, and also the steel production. Then we have desalination. The desalination and emerging proteins are really small drivers here. And also data centers, we can see that cheap electricity, we're considering 2 mega data centers. That's why it's quite big. So the key takeaways of this work is first that speed matter. If we don't electrify in time, we will be relying on direct air carbon capture technology or another carbon dioxide removal technology. Also, the late transition is really high, the energy demand that we have there. Also, if we want to reach net zero, we have to electrify as soon as possible. Then we have to look the energy system as an integrated system. We cannot look this as just economic growth. We have to look at net zero emissions and electricity capacity expansion to reach our goals. And also it's important to notice that this is not the only carbon dioxide removal technology that we should assess. We should assess a wider set of options, as for example, enhanced rock weathering or bioenergy carbon capture. So as future work, we want to use this data as an input of an optimization model to understand how the energy system will react to the incorporation of different drivers. So this is the work that we did as a group, the Sustainable Energy Research Group. So even though we are here assessing different demand projections, we also look at different options of how we can reach our different goals in New Zealand in an energy perspective. Thank you.